Welcome to Classwork 7.4, Textbook Section 5.3, Part 2. Today we're talking about half-angle formulas. So take a moment to pause the video and just write down the formulas below. And also note this box right here. This is for pre-calculus. If anybody in the class can derive these, so write out where they come from, they'll do a screen share and explain to the class, and I'll give your whole class one extra point on our next quiz, quiz 5.3. So that will be an extra credit opportunity for the entire class. Okay, now that you've written down the formulas, I'm going to add a couple notes here. Notice how these are plus or minus. The plus minus actually depends on the quadrant of theta over 2. That's important to understand. And what's really hard about these is that the sine and cosine formulas are pretty much identical. The main change or the only change is actually the sign. So what a student told me a long time ago to remember this is they like alliteration. So they said sad sign, sad meaning like negative. And I never really forgot that. So maybe that will help you too. Let's go to our first example. Find the exact value of cosine 112.5 degrees. So the first thing we're going to note is this thing is in quadrant 2. And that's going to tell us that in quadrant 2, cosine is negative. So we're going to know this thing is negative. So we'll come back to that. The first thing after that is we're going to rewrite 112.5 as something over 2. So simply multiply that by 2, and notice how that's 225 degrees. That's the exact same number. Now we can apply our formula, plus or minus the root of 1 plus cosine 225 degrees all over 2. Remember earlier we said that it's in quadrant 2, so this thing must be negative, so make that negative. So now we have negative, let's evaluate that. 1 minus root 2 over 2 all over 2. We're going to multiply by 2 over 2, and then we get negative root 2 minus root 2 over 4. If you left it like that, I would be okay with that. But since that's a 4 on the bottom, let's just take that out. Root 2 minus root 2 all over 2. And we'll leave the answer like that. But again, if you left it with the 4, I'd be okay with that. Because if it were like a 10 or a 20, I would tell you to leave it anyway. So there's the first example. Our next example is going to be this tan pi over 8. So let's move over here. The step is the same, but notice how the formula, there's no plus or minus there. So really we just have to focus on rewriting that as something over 2. So same thing, multiply pi over 8 times 2 over there, and you get pi over 4. So notice how that is the same thing as pi over 8. Pi over 4 over 2 is pi over 8. Now apply the formula, 1 minus cosine pi over 4 over sine pi over 4. And now we have 1 minus root 2 over 2 over root 2 over 2. So I'm going to show you a couple of things here. What we've been doing is clearing the complex fraction. So multiplying by 2 over 2, and then we get 2 minus root 2 all over root 2. Now the issue is there's a radical right there, and that looks pretty easy to simplify, but it's looking like a lot of work. So we're going to do a little trick here. Let's erase this. I'm going to de-rationalize this thing. I'm going to put this as 1 minus root 2, 1 minus root 2. Because if you think about it, root 2 over 2 is the same thing as 1 over root 2. Now the reason I did that is because watch what happens when I multiply by root 2 over root 2. You get root 2 minus 1 over 1. And look at that, way faster. The answer must be root 2 minus 1. Last example. So we look at this, hopefully you recognize this kind of setup. Cosine of alpha is negative 3/5. Alpha is between pi and 3 pi over 2. This is clearly a triangle problem. So let's draw a triangle. It must be in quadrant 3 because it tells us that. So let's draw a quadrant 3 triangle right there. That's alpha. This is negative 3, 5, That must be -4. And there's our triangle. Now sine of alpha over 2. So here's where we got to be careful. We know the formula is plus or minus the square root of 1 minus cosine alpha over 2. The issue is this plus or minus right here. Like, which one is it? Now, a lot of you want to say it's negative because look at that triangle and you can see the y value is negative. That's not entirely true because you have to focus on alpha over 2. Like, where is alpha over 2? So to do this, let's make a little chart here. Half angle, this is for a triangle, that's a triangle. Problems. This is going to be your guide here. And we can talk about this more after the video if it's not really clear. If I pick a quadrant 1 angle, like let's say I pick 30 degrees. If I half it, notice how it becomes 15 degrees, and that's still in quadrant 1. So if you're in quadrant 1, there's really nothing to worry about. Now let's say you're in quadrant 2, meaning theta's in quadrant 2. So let's pick an easy one, let's say like 120. If I half that, you get 60. So notice how the half angle of an angle in quadrant 2 actually goes to quadrant 1. Let's go to quadrant 3. Let's say you're in quadrant 3. Let's pick an easy one, like 240. If you half that, you get 120. And now you're in quadrant 2. And there's a weird one, quadrant 4. Let's say I pick 300. If you half 300, you get 150. Notice how you're still in quadrant 2. So what this is it's a little chart to help us figure out where actually is the triangle we're working with. Because what we have right here, this is the alpha triangle. This is alpha over 2. So notice how alpha is in quadrant 3 right here, which means alpha over 2, we're going to highlight this one. Alpha over 2, this must be quadrant 2. And sine in quadrant 2 is positive. So that thing is actually positive. So that is the tough part of the question. Once you have that, though, it's pretty straightforward. Let's evaluate. 1 minus cosine alpha is -3 over 5. That's all over 2. So that would be 1 plus 3/5 over 2. From here, let's just multiply by 5 over 5. So now we have the root of 8 over 10. That reduces to 4/5, which is 2 root 5 over 5. Done. Okay, here's B. So again, focus on this thing. Where is alpha over 2? And we said that's in quadrant 2. So think about cosine in quadrant 2. That must be negative. Write the formula. 1 plus cosine alpha over 2. Notice how it's pretty much identical to the last problem. 1 plus -3/5 all over 2. Multiply by 5 over 5. That's going to be 5 minus 3. That's 2 over 10, which is 1 over 5. And there it is, negative root 5 over 5. Done? Now the last one, the tan problem. So I'm just going to show you the formula just to make sure we can do it. 1 minus cosine alpha over sine alpha. It's really not too bad. Just 1 minus -3/5 over sine alpha, which is -4/5. Let's clean this up a little bit. Let's just make that 1 plus 3/5. Multiply by 5 over 5. That's going to be 8 over -4, which is -2. Done. Now we could have also done a shortcut. A bunch of you probably did that already. Just do sine of alpha over 2 over cosine of alpha over 2, and then you also get -2. That's it.